Hi all, welcome to the new video of computer network. In this video we are going to discuss data link controls. It is the service provided by the data link layer to provide reliable data transfer over physical medium. For example, in the half duplex mode, we know that station send data to another station, then the receiving station send back data to the source station. Then in the half duplex mode transmission, one device can only transmit the data at a time. If both the devices at the end of the links transmit the data simultaneously, they will collide and leads to the loss of the information. The data link layer provides the coordination among the devices so that no collision occurs. And the data link layer provides three functions. First one, line discipline; second, flow control; third, error control. Line discipline, flow control and error control. So in the line discipline, we deals with who should send the data. In the flow control, how much data should be sent, how much volume of data should be sent. Then in the error control, how error can be detected and corrected. In the previous class we had a discussion about error correction, error detection, humming code, all these things. Now we have line discipline. We have first one, line discipline. It is a functionality of this layer, that is data link layer, and provides the coordination among the link systems. Line discipline determines which device can send, when it can send the data line, and can be achieved in two ways. There are two ways to achieve this. enq bar eck, that is enq is acknowledged, then pollselect. First one, enquiry acknowledgement. It stands for enquiry acknowledgement, and it's used when there is no wrong receiver available on the link and having a dedicated path between the two devices. So enquiry acknowledgement is used when there is no wrong receiver available on the link and having a dedicated path between two devices, so that the device capable of receiving the transmission is the intended one. Now this line discipline enquiry coordinates which device will start the transmission and whether the recipient is ready or not. Here we have station 1 and 2 in the figure. See the figure. Then enquiry is there from station 1 to station 2. After enquiry, acknowledgement sent back to the station 1, then established connection, then data can be sent to station 2, then acknowledgement to station 1 for the transfer of data. Then the process continues, that is data transfer continues. Then at last station 2 and the acknowledgement signal of termination, that is end of data transfer. Now this is enquiry acknowledgement line discipline. Now moving to our another line discipline, that is pollselect. This method of line discipline works with those topologies where one device is as a primary and other devices are secondary devices. See, here we have one device as primary device, then we have station A secondary, B, C secondary. Three devices are there. So primary device will select the device, then again the acknowledgement will send back to the primary device, then data can be sent to the device, and at last acknowledgement signal to the primary device. So this is pollselect method. It's work on the topologies. Now our second data link control, second functionality, that is flow control. I told you how much data should be sent, So it is a set of procedures that tells the sender how much data it can transmit before the data overwhelms the receiver. The receiving device has limited speed and limited memory to store the data. Therefore the receiving device must be able to inform the sending device to stop the transmission temporarily before the limits are reached. So it requires a buffer, a block of memory for storing the information until they are processed. Two methods have been developed to control the flow of data. First one, stop and wait. Second, sliding window. So it requires a buffer, a block of memory for storing the information until they are processed. There are two methods have been developed to control the flow of data. First one, stop and wait. Second, sliding window. First one, stop and wait. In the stop and wait method, the sender waits for an acknowledgement after every frame it sends. When acknowledgement is received, then only next frame is sent. The process of alternately sending and waiting of frame continues until the sender transmits the end of transmission frame. Now, advantages of stop and wait. This method is simple as each frame is checked and acknowledged before the next frame is sent. So this is the advantage of stop and wait. Now the disadvantages of stop and wait. Stop and wait technique is inefficient to use as each frame must travel across all the way to the receiver and an acknowledgement travels all the way before the next frame is sent. Each frame sent and received uses the entire time need to traverse the link. So this is the disadvantage. Now sliding window. We are going to discuss sliding window. It is a method of flow control in which a sender can transmit the several frames before getting an acknowledgement. In sliding window control, multiple frames can be sent one after the another due to which capacity of the communication channel can be utilized efficiently. Sliding window refers to imaginary boxes at both the sender and receiver end. The window can hold the frames at either end and it provides the upper limit on the number of frames that can be transmitted before the acknowledgement. Frames can be acknowledged even when the window is not completely filled. See, we have center window here, then direction is there to left to right. This wall moves to the right when a frame is sent. This wall moves to the right when an acknowledgement is received. So this is sliding window strategy. It is a method of flow control in which a sender can transmit the several frames before getting an acknowledgement, and multiple frames can be sent one after the another due to which capacity of the communication channel can be utilized efficiently. Now our third point, that is error control in data link control. Now error control is techniques of error detection and retransmission. We already discussed that. Then categories of error controls are the error control can be, here we have stop and wait ARQ, then sliding window ARQ. In this sliding window ARQ we have go back in and selective reject. Now first one, stop and wait ARQ. It is a technique used to retransmit the data in case of damaged or lost frames. This technique works on the principle that the sender will not transmit the next frame until it receives the acknowledgement of the last transmitted frame. So this method is used to retransmit the data in case of damaged or lost frames. Now sliding window ARQ. It is a technique used to continuous transmission error control, and in the case the sender keeps the copies of all the transmitted frames until they have been acknowledged. Now the receiver can send either NAC or ACK depending on the condition. The sliding window ARQ is equipped with the timer to handle the lost acknowledgements. Now two protocols used in sliding window ARQ, go back in ARQ and selective reject ARQ. Go back in ARQ. In go back in ARQ protocol, if one frame is lost or damaged, then it retransmits all the frames, after which it does not receive the positive acknowledgement. Three possibilities can occur for retransmission, that is, first one, damaged frame. When the frame is damaged, then the receiver sends a NAC frame. Second, lost data frame. The sending device retransmits the frame indicated by NAC and as well as the frame transmitted after the lost frame. Now lost acknowledgement, the third point. If the acknowledgement has not been received within the time limit, then the sender retransmit the frame since the last acknowledgement. So this is the figure. Sender send data 0 1 2 3, then acknowledgement received ck2 and nak2, then error will be reported or it can be discarded. There are two frames, that is one frame is error, then first one discarded. So two acknowledgement, then here resend that error contained and disregarded data again. So this is go back ARQ. Now selective reject ARQ. This technique is more efficient than go back in ARQ. In this technique, only those frames are retransmitted for which negative acknowledgement has been received. The receiver storage buffer keeps all the damaged frames on hold until the frame in error is correctly received. So the receiver must have an appropriate logic for reinserting the frames in a corrected order. The sender must consist of a searching mechanism that selects only the requested frame for retransmission. Here we have data 0 1 2, then NAK is the 2 error in the 2 second frame, then all the data, that is 3 4 4 2, like that it can be resent. So error in frame 2, so all the data again can be sent to the receiver. So this method is selective reject ARQ. You can selectively reject ARQ. Now in the next video we will come with multiple access protocols in computer network. Thank you.